All right, number 8, we have a graph. We want to determine if the graph can represent a polynomial function. If so, we're going to assume the end behavior and all turning points are represented. And then we're going to determine the minimum degree of the polynomial. We're going to determine whether the leading coefficient is positive or negative based on the end behavior, and whether the degree of the polynomial is even or odd. And then we're going to approximate the real zeros of the function and determine their multiplicities are even or odd. Okay, so let's talk about this graph. So because we can see everything, this is the graph of a polynomial. This is the basic structure of them. Remember earlier we talked about the even and odd, and either both ends will go up or both ends will go down, and then one side might go up and one side might go down, or vice versa. Those might be flipped. Okay, so these were the 4 scenarios. So we are looking at, again, it's kind of off. We're looking at this scenario here where both endpoints go up. So let's talk about what we can deduce from this graph. So let's talk about turning points. Turning points, you can figure out how many times this graph is going to turn, which is change direction. Like if it's going up and then it turns to go down, and then it changes and goes back up. So that would be 2 turning points. The number of turning points is equal to your degree minus 1. Okay, so degree minus 1 equals turning points. All right, so from this graph, we can see that going from left to right, it is going down, and then it starts going up. So that's 1 turning point. Then it's going from up, and it changes going down. That's 2, and going down, and then it changes going back up. So it changes 3 times. So my turning points is 3. So if we write an equation, 3 equals 1 minus something, x, we can solve for x by adding 1. And we get x equals 4. So we can see that this is a 4th degree polynomial. That tells me, the degree tells me max number of zeros. And all this you can kind of get in the reading. Okay, so this tells me how many times the graph could cross the x-axis, which will be 4. The fact that we are getting an even degree matches with the end behavior, because both endpoints are going the same direction. That happens when it's even. And so based on this A, it says the minimum degree of the polynomial, I would say minimum degree of 4. Okay, part B, it says determine whether the leading coefficient is positive or negative. We would say that's going to be positive, because we can see both endpoints are going up to positive infinity. And it says whether the degree of the polynomial is even or odd. It's also going to be even. Okay, we got a degree of 4. Part C, approximate the real zeros and determine their multiplicities, even or odd. Okay, so determining zeros and their multiplicity. When a line crosses the x-axis, that usually guarantees an odd multiplicity 1. Sometimes it flattens out. Like if this was the x-axis and the graph kind of comes and kind of like flattens out, that would still be odd, but that would let me know maybe it has a higher multiplicity than 1. But because it's just going straight across, that tells me odd and crosses at 1. When we have an even multiplicity, it's going to touch the x-axis. Like it might come down here and touch and turn around. So that'll be an even x-axis. So odd is going to cross, even is going to touch. So we are looking at zeros of x equals negative 2. We also have one at x equals negative 1. And then at positive 2, we can see the graph comes down and touches. So 2 looks like a multiplicity of 2. And all these other ones are looking at multiplicity of 1. Okay, so I think that will answer all of the different parts. Let's enter that. So graph has 3 turning points. Therefore, the minimum degree of the polynomial is 4. Determine whether the leading coefficient is positive and based on the end behavior. So end behavior is up and to the left, and up and to the right. Coefficient is positive. Degree is even. Approximate the real zeros. The real zeros of the function correspond to the x-intercept. So zeros, x-intercepts, roots, all of those are x-intercept terms. The graph has x-intercepts at -2, -1. They cross, and then the graph touches and turns around at 2, 0. And then it says, therefore, -1, -2 are real zeros of odd multiplicity, and 2 is a real zero of even multiplicity.